Okay, so today we are learning about hyperbolas. This is our last conic section. All right, so hyperbola is defined as the set of all points. The difference of whose distance from the two fixed points is constant. So it's like an ellipse, except for the whole difference rather than sum. And the standard equation you'll see is very, very similar. The only difference is that this is a minus sign and not a plus sign. And that minus sign is important because sometimes x will be first, like in the case of this green one that I've circled, and then sometimes y will be first, in the case of the one I underlined there. And that makes a difference as to whether your hyperbola goes up and down, like it will if the y comes first, or left and right, like it would if the x came first. So the important features of a hyperbola, some of them are very familiar. We still have foci. We have a center. We have vertices. The vertices are these 2 points at the end of the hyperbolas. And we have what's called a transverse axis. This is the distance between the vertices. And we also have asymptotes. By the way, the equation for our foci is the standard Pythagorean theorem, not like in ellipses where that plus is a minus. So I'm going to start us off with an example. I'm going to show you a hyperbola and how you graph it and find all of these important features. So to start with, here's the example I've chosen. This example does not have a center of 0, 0. And again, I like to work with the picture. It makes everything seem easier. So my center here is -1, 2. I'm going to plot that. I still am going to determine an x radius and a y radius. So the x radius would be 4. Oh, that's the y radius. So the x radius is 4. There we go. And then the y radius is 3. So I'll go up and down 3 from the center. Okay, so one thing that's different here is now in an ellipse we would be done. We would just connect all of these vertices and co-vertices. This is not how we do a hyperbola. Instead, what you're going to do with a hyperbola is you're going to connect these points with a box. This box is going to determine the asymptotes that you're going to use to graph the hyperbola with. So now, from corner to corner, through the center, you're going to put in the asymptotes of the hyperbola. And then the last thing to do is to go ahead and draw in the hyperbola. In this example, the x came first. That means I'm going to use my x radius vertices here, and these are my vertices. And I'm going to draw in the hyperbola using those points as the vertices and approaching my asymptotes from there. If the y had come first, then I would do the one up here. But the y doesn't come first, so I'm not going to do that. Okay, so now we can answer a lot of questions. What is the center of this? Well, my center was -1, 2. I can answer what the vertices are. They're going to be the ones here at the ends of my hyperbolas. And so their y-coordinate is 2, but their x-coordinate, I took the x-coordinate of the center, -1, and I went left and right 4. So -1 plus or minus 4. You can go ahead and write that as -5, 2 and -3, 2 if you'd like for 3, 2. But this one's okay as well. We also need to find the foci. Okay, so to find the foci, we're still using the C notation. So we're going to say C squared is A squared plus B squared. And A squared and B squared are the x and y radiuses again. And it doesn't matter who's who this time. I don't have to do bigger minus smaller. So C squared is 25 and C is 5. That means from my center, I'll go left and right 5. So I think that's one more. So here's one focus, and here's the other focus. And so my foci are -1 plus or minus 5, 2. Again, those are all going to be on that same axis. In ellipses, that was called the major axis. And hyperbolas, this is called the transverse axis, right here. This is going to be your transverse axis. And I actually drew the transverse axis too big. It doesn't extend, I don't believe. I think it just goes to the vertices. Okay. And finally, let's talk about our asymptotes. You are going to have to determine the equations of the asymptotes. And here is a general formula for what the equations of the asymptotes are going to be. They're going to be y minus k equals plus or minus a over b x minus h. Now, this a over b, it's not necessarily a over b. It's always y radius over x radius. Y radius over x radius. So in our case, for this particular picture, the equations of my asymptotes are y minus 2 equals plus minus the y radius over the x radius. That's 3 over 4. So 3/4 x minus x plus 1. So x minus negative 1. These are the equations of the asymptotes. And the reason why that works is because you go from the center, you go down 3 over 4. So that's a slope of 3/4. That's how we got that y radius over x radius thing. And that's why it's always y to x, because it's rise to run. And you can add the 2 over if you'd like, but this is fine as well. Okay, so I have a few more examples we're going to do. In this next example, we're going to find all of those important features. However, if you'll notice, the equation is not yet in standard form. So the first thing that we want to do here is put it in standard form, which is going to mean completing the square. If you look, the x's are fine. I don't have an x squared and an x. I just have the x squared. So I have nothing to do to that. But my y's are not okay. First of all, I've got a negative 9 here. I'm going to factor that negative 9 out. And so I will have y squared minus 4y. That's what's going to be left. And then I'm going to add the 72 to the other side. So the only thing that needs the square completed on it is the y's, or the y's. And so let's add in our magical number here. I'm going to take half of the b, which is negative 2, and square it. Negative 2 squared is 4. Whatever you add to one side of the equation, you have to add to the other side as well. But be careful. Remember, you're adding a 4 inside these parentheses here. I've added 4 inside the parentheses. To the actual left side of the equals, I actually added negative 9 times 4 because of this negative 9 sitting out here. So you have negative 9 times 4. And so I have to add negative 9 times 4, which is negative 36, to the right side as well. All right, now I'm all set up to start to get standard form. I'm going to go ahead and factor my y's, and I get the perfect square, y minus 2 times y minus 2. And then on the right side, I get 36. So we're not quite in standard form. We have this pesky minus 9 coefficient, but more, we have the 36 on the right side. This has to be a 1. And remember last time, the way we make it into a 1 is we divide by 36 on each side. So on the right side, I've got my desired equals 1. And then on the left side, you have to be careful. You're going to distribute the 36. So I've got x squared over 36 minus, and then over here with the y's, the 9 would cancel and make that a 4. And now we're looking at a hyperbola in beautiful standard form. So let's go ahead and do our rough sketch right now. So to sketch this, it looks like my center is going to be 0, 2. And my x radius is 6. I'm going to put in 6 from each side. And my y radius is 2. And now I'm going to make this box. And then I'm going to go corner to corner through the center to get my asymptotes in place. Okay. And the x came first again. Okay, I did 2 in a row where the x came first. That means we're going to open left and right, and our transverse axis is horizontal. Otherwise, we would be opening up or down. That means I know what my vertices are. My vertices are the x coordinate of the center, which is 0, plus or minus 6. And then the y coordinate is going to stay at 2. Let's go ahead and find our sub-side. So c squared equals a squared plus b squared. I don't think this is going to be quite as pretty. So c squared equals 36 plus 4, or 40. So my focus is the square root of 40, or 2 radical 10. That's somewhere between 6 and 7. So here and here. And those as coordinate points, I would again take my center x coordinate, which is 0, and then plus or minus square root of 40. So plus or minus 2 radical 10, and then the y is the same height of 2. So comma 2. All right, now I have my focus, my center, my vertices. Let's work on those asymptotes. So I'm going to have y minus 2 equals plus or minus, because there are 2 asymptotes, there are 2 lines. The rise over the run is 2 over 6, which reduces, let's reduce that to 1/3. And then x minus h, so that's just x. So we get y equals plus or minus 1/3 x plus 2. That's the equation of those are the equations of those 2 dotted diagonal lines. And I think we're done. I think we found all the important features of the hyperbola. Okay, there's no eccentricity on this one like there was on the ellipse. All right, now we're going to go backwards. I'm going to give you some information about the hyperbola, and you need to come up with the standard form. Again, I like to work from a sketch. It helps me figure everything out. So my vertices are 2, 3, and 2, negative 3. Oh, this one's opening up and down. And I can get that just by figuring out, just by drawing a sketch of the vertices. And then the foci are 2, 6, and 2, negative 6. Focus. Another focus, so I must go somehow like this, and I'll have asymptotes around it. But I don't need to really worry about the sketch. That's just to help me figure out the standard form. So based on that, let's figure out where the center should be. It should be in the middle here at 2, comma 0. Okay. So then in my standard form, well, in this one, y is opening up. We're opening vertically, so the y comes first. Y minus k squared minus x minus h squared. And again, I don't worry about which one's a or which one's b. Okay. So my y coordinate is of the center is 0, so I have y squared over, and I can see that my y-axis here, or my y radius is 3. So y squared over 9 minus x minus 2 squared over, now I don't know what b squared is, equals 1. But we're almost done. I just have to figure out what b squared is, and I can do that with the focus. So we know that c squared equals a squared plus b squared. The focus was 6 away, so that gives me 36 as c squared equals 3 squared plus b squared. Minus 9, that's 27. Don't worry about the square root, you just want to know what b squared is. And so I'm just going to replace the b squared with 27. And that's the equation of my hyperbola in standard form. Last example, we haven't been doing all that many implicit derivatives, so I want to make sure that you can still do these. So this is the one you're going to get to do on your own. Find dy dx.